Hey everyone, welcome to the very last video in our series on the reactions of chapter 9. In this video, we're going to kind of talk about three reactions in one video. Sorry, but they're all very closely related. So we're going to be talking about reactions of terminal alkynes. Okay, so reactions of terminal alkynes. And like I said, I promise that these are all related to each other, so that's the only reason that I'm making one video to talk about three reactions. The very first reaction is going to be I take some terminal alkyne, all right? So we'll take this terminal alkyne, for example, and I react it with a strong base, NaNH2, okay, in liquid ammonia, so liquid NH3, all right? Okay, so now what this does is this triple bond here, right? The end of this triple bond has a hydrogen on it, right? Basically, this NaNH2 is a very strong base. NH2 minus is going to come in, take a hydrogen. And what that leaves me with is it leaves me with this. That leaves me with this alkyne, which is deprotonated now. It's a deprotonated alkyne. Any deprotonated terminal alkyne is an acetylide. Okay, so this leaves me with an acetylide. So acetylides can be used for a lot of different things, but so this is how we form an acetylide. So we can say this is a formation of acetylides. Excuse me. So all I have to do is just put in NaNH2 with some liquid ammonia. All right. That's all I really have to do. Okay. So this is the first kind of reaction that we're doing here. So let's not harp on this too much, but let's take a look at another example here. So we can look at NaNH2 in liquid ammonia with this terminal alkyne. And again, all it does is just get a negative charge and a lone pair right there. Okay. So now, what I can do is I can take these acetylides, okay, and I can do things with them, all right, because this is negatively charged. So and they're good nucleophiles and good bases. So I can do SN2 or I can do E2 with acetylides. So SN2 and E2 with acetylides. Okay, so SN2 and E2 with acetylides. So let's look at SN2 first, all right? So what I'm going to do is I'm going to start with this alkyne again. And as a first step, I'm going to put in NaNH2. And then as a second step, I'm going to put in CH3I. Okay, so CH3I is methyl iodine, right? So what's going to happen is the step one is going to deprotonate my alkyne. Okay, so I'm going to end up with this after step one, right? And then methyl iodide is going to get attacked by this negative charge, right? Because strong negatively charged nucleophiles are good for SN2. So that means that this reaction is going to be favorable, right? So this is just going to come in here, attack this carbon, and then iodine leaves. So in totality, what I'm doing is just adding CH3 to this, right? So that means that my product is going to be this. All right. All I've done is just add a CH3. Okay. So that's how I need to think about these reactions, okay, whenever I'm doing them. So if I'm doing an SN2, all right, so let's take a look at a different one. Why not? We'll do this alkyne again, sure. So again, step one is going to be NaNH2. And then step two is just going to be some alkyl halide. So let's do this alkyl halide. So this is a 3-carbon alkyl halide. So now all I need to do is just remember that these three carbons, I'm just going to be adding to this alkyne. All right. So the alkyne, I just draw it, right? And then I add three carbons. 1, 2, 3. And I'm done. Okay. So this is going to be my product. All right. And so again, all that is happening here is that I am doing SN2 with this, right? So this is coming in here and attacking there, and then the chlorine leaves. All right. That's it. Okay. Pretty straightforward. And so if I have a primary or methyl halide, then this is going to happen. But I can also do E2, right? So again, let's take a look at this alkyne. Sure, why not? And NaNH2. And then as a second step, we'll put in this alkyl halide. This is a 3-degree alkyl halide, right? 3-degree alkyl halides are horrible for SN2, so this is definitely not going to go through SN2. So what's going to happen is this terminal alkyne is going to get deprotonated in the first step, and then I have this. Okay, so what's going to happen is it's going to do E2. So again, review of E2. A hydrogen is going to get taken. It's going to form a double bond, and then chlorine's going to leave. Okay, so then what that gets me at the end is going to be this alkene. All right. So in these, I'm doing SN2. And in this last one here, this one is E2. All right. So SN2 and E2 are both possible with these acetylides. Okay. Both of these are possible. The only other thing that I want to mention very briefly is that I can do the SN2 addition twice. Okay. So let's take a look at this this ethyne again. All right. And as a first step, I'm going to put in excess NaNH2 or two equivalents, right? It doesn't really matter. I'm going to be putting in a lot of NaNH2. And then as a second step, okay, I'm going to be putting in this, okay? So now this is what's going to happen, okay? There's two ways to do this. This is the first way to do it. So in the first step, I deprotonate one side of the alkyne, right? And then I form this. And this can react with this again, right? SN2. Okay, so this is an SN2 reaction. And then so the first thing I'm going to get is I'm going to get two carbons added to my alkyne, right? I get this. But I have excess NaNH2, and this is still terminal, right? I still have a hydrogen here that I can take off. So it's going to happen again, right? So this is going to get deprotonated again. So if it gets deprotonated again, then I get this, right? After I get this, it can do SN2 again. So I add two carbons twice. Okay, I add two carbons twice. So this is going to be my product with excess NaNH2. All right. So this can happen twice. All right. And I can add two different groups if I want. I don't have to add the same group. So I can add NaNH2 to something. And again, we're going to be using this. And then as a second step, I can put in some alkyl halide. And then as a third step, I can put in NaNH2 again. And then as a fourth step, I can put in another alkyl halide. Let's put in this one. So now what's going to happen is in the first step, I add two carbons. And then in the second step, I add this ring. Okay. So let's add the two carbons first. So in the first step, I add two carbons on one side, okay? And then I isolate it, do NaNH2 again, and then I add this ring structure again, okay? Or I add this ring structure on the other side. So then I get this, okay? And this can only be done with ethyne, right? If I didn't have ethyne, if I started with something like this, well, I can only deprotonate this once because there's just one hydrogen, right? There's just one hydrogen on this, so I can only deprotonate this once. In this case, there's two hydrogens on this one, right? There's two hydrogens on ethyne. I have 1, 2, so I can deprotonate this 1, 2 times, okay? So that's why I can do this twice with these, all right? So again, I'm just adding this group, and I'm adding 2 carbons. All right, so that's why I'm getting these products here. So let me get rid of this. Okay, so this is explanation of SN2 with acetylides. There's one other thing that I can do with acetylides that is important. Okay, so I can do addition to carbonyls. Okay, addition to carbonyl groups. So whenever I do addition to carbonyl groups with acetylides, it's going to be slightly different, okay? So let's start off with a simple one here. Again, my first step is going to be NaNH2, right? And then, again, I haven't been writing this, but it is technically in liquid ammonia, but I'm not being a stickler about that right now, so I'm not too worried about it, but it is usually in liquid ammonia. So if you see that, don't let that trick you. All right. But NaH2 is the first step. Deprotonate that. Okay. And then as a second step, I'm going to put in some carbonyl group. And then as a third step, I put in acid. All right. So let's kind of talk through this and what's going on. All right. So after I deprotonate, right? After I deprotonate, then I get this. And if I look at this ketone, this CO bond is polar, right? So this up here is slightly negative, and this carbon is slightly positive. Okay, so since this carbon is slightly positive, then that means that this negative charge is going to be attracted to it, so it can attack here. All right, so it can attack there. And since it can attack there, then what happens is I get this intermediate, all right? And then once I throw in acid, that just protonates that oxygen to make an OH. Okay. So if you look at this, okay, all I've really done is I've taken the carbonyl group, turned it into an OH, and added the alkyne to the carbonyl. Okay. So that's all I've done. So this is my product. So now let's do a couple of examples, a couple of other examples. Okay. And I can make this alkyne as complicated as I want to, honestly. So let's do something like this. Whoop. Terminal alkyne, sorry. So first step, NaNH2 in liquid ammonia. And then as a second step, we don't have to add a ketone. We can add anything, right? We can add a ketone or an aldehyde. So in this case, I'm going to add an aldehyde, PHCHO. And then as a third step, we just throw in some acid. Okay. So PHCHO. So what does PHCHO look like? Well, PHCHO looks like this. pH is a phenyl ring. And then CHO is an aldehyde. So this is CHO. Okay, so this is PHCHO right here. All right. So all I'm going to do is turn this carbonyl group into an OH. So let me do that. So carbonyl group turned into an OH. And then I just add this alkyne. I'm done. That's it. Okay. That's all I have to do. And I can count my carbons to make sure that it's correct as well, right? all my carbons should end up in my product. But that's it, right? That's all I'm doing. Let's look at another example here. So let's look at, I don't know. Let's look at this one. Whoop, not H3O plus yet. That's 3. And then as a second step, let's put in this. I need a little bit more space here to draw this ketone. So as a second step, we're going to put in this ketone. And then as a third step, we're going to throw in some acid. Okay. So again, I take my ketone or my carbonyl group and it becomes a OH. And then I just add my alkyne. So this is 1, 2, 3, 4, 5 carbons. So 1, 2, 3, 4, 5 carbons. 1, 2, 3, 4, 5 carbons. So this is my product. Okay. So again, all I do, carbonyl becomes an OH, and then I turn the alkyne into a bonded alkyne to the group. Okay, let me redraw this. It's not the greatest drawing. Okay, so that's my product. All right. And we're not going to worry about the mechanism too much, but mechanistically, this is what's going on. All right. So again, I deprotonate this. This comes in and attacks. Then I get this. And then with acid, I protonate it and get the alcohol. Okay. There's a very similar mechanism that we actually will do in chapter 10. So that's why I'm not worrying about it too much here. Okay. So I think that if you're able to just recognize that whenever I have these 3 steps in these orders that I'm doing addition to a carbonyl group with this, then I don't think you're going to have any problem with this. So I just turn the carbonyl into an OH, and then I add whatever my alkyne is, and I'm done. Okay. So hopefully this video was helpful. Again, we did addition of carbonyls, we did SN2, we did E2, and we did formation of terminal acetylides. So we did a whole lot in this video. So hopefully you're all good with everything. And this is the very last video for chapter 9. So if you've watched all the videos for chapter 9, congrats, you're done with chapter 9. So now we're going to be moving on to chapter 10. There's only going to be 4 videos in chapter 10, but chapter 10 is very important. So I would definitely encourage you to tune into those videos. And I hope that I will see you there.